Combined gas law states the relationship between pressure, volume, and temperature of a fixed unit of gas. Pressure is inversely proportional to volume and directly proportional to temperature.
In this problem, our givens are volume 1 is 435 milliliters. Our pressure 1 is 1.10 atm. Our temperature 1 is 30.0 Celsius, which adding 273 Kelvin is equal to 303 Kelvin. Our pressure 2 is 0.734 atm, and our temperature 2 is 5.00 Celsius. When adding 273 Kelvin, we get 278 Kelvin. And our constant is number of particles. So P1 V1 over T1 is equal to P2 V2 over T2. Then we get V2 is equal to P1 V1 T2 over P2 T1. Then plugging in our numbers, 1.10 atm times 435 milliliters times 278 Kelvin over 0.734 atm and 303 Kelvin. Then our units cancel, and we're left with 598 milliliters, and we have 3 sig figs. And then our pressure went down, temperature went down, and volume went up. Standard pressure is 1 atm.
This is Boyle's law. Formula is P1 V1 equals P2 V2. And the givens are V1 equals 560.0 milliliters. P1 equals 1.0 atm. V2 equals 780.0 milliliters, and P2 is the unknown. First step, rewrite the equation. It would be P2 equals P1 V1 over V2. Then you plug in the numbers. P2 equals 1.0 atm. 560.0 milliliters. Draw a line. Divided by 780.0 milliliters. Multiply the top together and divide it by the bottom. P2 would equal 0.7179 atm. Then you have to check for the number of sig figs, and there's 4 with the given. 1, 2, 3, 4. box or squiggle the answer in the thing. And then you have to write the V goes up, P goes down. That's how you do a Boyle's Law.
Quick review. Step 1, write the given, constant, and unknown. Step 2, rewrite the equation. Step 3, plug it in, it being the givens. And then 4, sig figs.